Write each expression with a single exponent. The base to the power of e means the base multiplied times itself, e times whatever the exponent is. For instance, 10 to the third times 10 to the ninth power would be 10 to the third, or 10 3 times 10 9 times. But if we take this and put them together, we also found out that if we count, there are 12 tens that are multiplied together. So instead of following the long way, we found out that we could take the exponents on that 10, same base. We can add the exponents when the bases are multiplied. So we get 10 to the 12th power. In the same manner, this 10 has a power of 1, so we can take 10 to the first plus 4, which gives us 10 to the 5th power. 10 to the 7th times 10 to the 10th would be 10 to the 10th plus 7, which would give us 10 to the 17th power. It's certainly easier than writing out 17 tens. 10 to the third times 10 to the third power would be 10 to the third plus the 3, which gives us 10 to the 6th power. 10 to the 5th plus 12 gives us 10 to the 17th power. And then 10 to the 6th, 3 separate times, which is really saying 10 to the 6th to the 3rd power, which we got into the next lesson, means 10 to the 6th plus 6 plus 6, which gives us 10 to the 18th power. This is much easier than writing it 18 times. For problem number 2, it says a large rectangular swimming pool is 1,000 feet long, 100 feet wide, and the pool is filled 10 feet deep and is filled to the top. I drew the picture of the dimensions of the pool. I know the area of the surface of the water in the pool is length times width, which will give me the area of the top of the pool that is 100 by 1,000 feet. When I multiply that, I get 100,000 cubic square feet. So the area is 100,000 square feet for the top of that pool. We also know that the pool wants to know what the pool holds. So we know the volume is the area of the base times the height. The area of the base is 100,000 square feet times 10. When I multiply that, I get 1 million cubic feet of water that the pool would hold. Then it wants us to change those to powers of 10. Well, if I look at the area, that is 10 to the 5th power. 10 is the fun one because it's very easy to change to an exponential form. The volume as well is 10 to a power of 1, 2, 3, 4, 5, 6. So it would be 10 to the 6 cubic feet. For question 3, it says write an expression with a single exponent. We have 10 to the 7th power squared, or 10 to the 7th power raised to the 2nd power. That means 10 to the 7th multiplied times itself twice. Well, we know from previous that we can add the exponents, 10 raised to the 7th plus the 7th power. But 7 plus 7 is simply 7 times 2. So we can also, when we have a power raised to a power, we can multiply the exponents to find that 10 to the 7th times 2 is 10 to the 14th power. So 10 to the 6th raised to the 3rd power would be 6 times 3, or 10 to the 18th power. Here we have 10 to the 3 times 2 power, which gives us 10 to the 6th. 10 to the 9 times 3 power, which gives us 10 to the 27th. That's much easier than writing a 1 with 27 zeros behind it. Here we have 10 to the 2 times 3 power, which gives us 10 to the 6th power. And here we have 10 to the 5 times 7th power, which is 10 to the 35th power. I certainly don't want to write 35 zeros, if I can help it. For question 4, it says you have 1,000,000 number cubes, each measuring 1 inch on a side. If you stack the cubes on top of one another to make an enormous tower, how high would they reach? Explain your reasoning. To save us a little time, I wrote this ahead of time, so follow along. If you stacked 1,000,000-inch cubes, the tower would stand 1,000,000 inches tall. Or I could convert that to feet, which dividing by 12, which would give me about 83,333 feet. Which, if I convert that to yards by dividing by 3, would give us nearly 27,778 yards. So that's still hard to kind of fathom. So I divided by 1,780 yards in a mile to get about 16, as little less than 16 miles tall that tower would be. Next, we're asked, if you arrange the cubes on the floor to make a square, would the square fit in your classroom? What would its dimensions be? Explain your reasoning. Well, 1,000,000 cubes would make a square that is 1,000 by 1,000 inches. So 1,000 cubes on each side. 1,000 inches is 83 1/3 feet. So the cubes would make a square 83 1/3 feet by 83 1/3 feet on each side, which is at least twice, if not 3 times, as long and wide as the classroom. Question C says, if you layered the cubes to make one big cube, what would the dimensions of the big cube be? Explain your reasoning. If you made a cube from the blocks, 1,000,000 of them, the dimensions would be 100 inches by 100 inches by 100 inches, length, width, and height, or 8 1/3 feet wide by 8 1/3 feet long by 8 1/3 feet tall. However, it would fit in the classroom. Today we're going to jump into some more exponents.